Hello friends, in this project we are going to explain a title about cloud sensor security framework against for various attacks in the network. We are grateful to our HOD madam Mr. C. Chandravadi and the project guide Mr. V. Sababadi and the project team member R. Lokeshwari, S. Perili, S. Sangavi. The main aim of this project is to take a risk assessment of every attack and deploy the code image in the distributed manner in a secure way, which allows multiple authorized network user update the code image on the different nodes without involving the base station and prevent the denial of service attack, which makes a severe consequence on the network availability. A sensor cloud consists of various heterogeneous wireless network. The WSN may have a different owner and run a wide variety of user application on a demand in a wireless communication media. Hence, they are susceptible to a various security attacks. Thus, the need to execute to formulate effective and efficient security measures that safeguard these applications impact from the attack in a sensor cloud. However, analyzing the impact of different networks and their cause-consequence relationship is prerequisite before a security measure can be either developed or deployed. In this paper, we propose a risk assessment framework or WSN in a sensor cloud that utilize the database. Code dissemination is a process of propagating a new program image or a relevant command to a sensor node through wireless link after a WSN is deployed. Due to the need of removing a bugs and adding a functionality, code dissemination is an important operation function of WSN, and a WSN is usually deployed in the user environment. Dissemination is and will continue to be a major concern. Most code dissemination protocols are based on the centralized approach in which only a base station has the authority to initiate the code dissemination. However, it is a considerable and sometimes necessary to code dissemination image in a distributed manner. Several code dissemination protocols have been proposed to propagate a new code image in a WSN. DLOG is included in a tiny distribution. However, since a design of DLOG did not take a security in consideration, there have been several extensions to DLOG to provide a security protection of code dissemination. Among them, Zilog enjoy both strong security and high efficiency. However, all the code dissemination protocols are based on the centralized approach, which assumes the existence of base station and other base station has the authority to reprogram a sensor node. Unfortunately, these are WSN based. Unfortunately, there are WSN having no base station at all. For example, a military WSN is a battlefield to monitor enemy activities. A WSN deployed among an international border to monitor a weapon, sublink or a human traffic. And the WSN situated in the remote area of national park monitoring the illegal activities. In this paper, we propose a risk assessment framework for WSN in a sensor cloud that utilizes a database. Using a proposed risk assessment framework allows a security administrator to better understand the threats present and take a necessary action against them. Firstly, we consider the denial of service attack on the code dissemination, which has severe consequence on the network availability, as well as propose and implement two approach to defeat DOS attack. Secondly, the proposed code dissemination protocol is based on a secure and efficient proxy signature by warranty technique. We consider how to avoid reprogramming conflict and support dynamic participation. A secure code dissemination protocol should satisfy the following requirement: integrity of code image, freshness, DOS attack resistant, node compromise tolerance, distributed, supporting different user privilege, partial reprogram capability, avoiding reprogramming conflicts, user traceability, scalability, dynamic participation. There are 6 or 7 attacks is basically involved: key mismatch, user access, region, registered region, old version, hash fail, denial of service, access over. Modules: there are 4 modules involved in a project: network formulation and user registration, installing code image, resisting DOS, predicted impact level of attack and report to a admin. Network formulation and user registration: a network is first formed with different region are splitted based on the sensor range. The region are fully controlled by a network admin. Keys are shared with the sensor in the different region by a network admin. User requests are proposed and the key are issued for issuing warrant. Only a public key of network owner is preloaded on each node before deployment. Attacks raised in a module 1 are registered region. If a user present in the network by registering one region, then same region cannot be registered by other user. Second module is installing code images. Proper registration of user is updated in the admin table. After the network is deployed, admin should provide issue warrant to a user for describing the user privilege that the user is able to update the code image. There are 3 steps involved in this module: system initialization, user pre-processing, sensor node verification. Attacks raised in a module 2 are key mismatch. If admin asks his public key to every new user entered in the network, if the user reply a wrong public key to admin, means admin remove the user from the network. User exist. If more than one user tend to exit in the network, then the user attack will rise. Old version: the version should be detected only upon an increasing order. Code generation is only by using a new version, otherwise it will become an attack. Resisting attack: resisting DOS is a third attack. Third module rise or a attack rise. This region head checks periodically whether a DOS is suspected. If found from the user is validated, then the user by asking a puzzle periodically before a data sent in a particular, the node attached a unique puzzle into a beacon message and require a solution of a puzzle to be attached in a signature message. The node commits resource to propose a signature message only when a solution is correct. If the answer for a puzzle is correct, it sends the data. Otherwise, it informs all the node in the region about the attack and suspect to drop the user and not to send the data further to specified user. Attacks raised in the third module is access over DOS. If the user exceeds the warrant, access over attack is formed. If the attacker generated code continuously, then the DOS is suspected. In 4 module, we explain about predicted impact level of attack and report to a admin. For each and every attack, weightage and recovery cost is calculated. Database contains 6 fields, namely attacker, attacker name, type of attack, time of attack, recovery time of attack, and impact level of attack. The impact level of attack is updated based on the weightage, recovery cost, and recovery time of attack. Then this database is exported in the PDF form to the admin. Conclusion: in this paper, we presented a risk assessment framework for WSN in a sensor environment. We depict the cause-consequence relationship for an attack on a WSN using a database. Thus, we deployed a code image in a distributed manner and as a risk assessment of every attack successfully. Enhancement: It initiates to admin about an attack performed in the network periodically in the order to take a necessary step of preventing these attacks in future. Maintenance of the database, which include overall attack information with recovery costs rather than a plotted in the graph. Software requirements are Windows operating XP and above, JDK, Java FX 1.3. Hardware requirements are hard disk 8 GB and above, RAM 1 GB and above, processor are Pentium 4 and above. Algorithm used are RSA for encryption and decryption, HMAC for signature, KeyMac for proxy key. Technology used the Java networking.